that in a small space and over a small amount of time, you can't create or destroy matter. You can turn it into energy and back, but that's not creating or destroying matter. It's still all the same stuff. But conservation laws kind of naturally extend that principle to the universe as a whole. And people are like, yeah, but we had to start with nothing, and then how did we get something? Because that makes no sense, because you're getting something for nothing.
That's right. We had this discussion. I
Yeah.
still don't understand what you're talking about. Go ahead.
Well,
Try again.
anyway.
Try again.
Well, I'm nah, because
No, it's important. See what you can do with that. I mean, can you explain it a little more or not?
Well, a nice theory, which a lot of scientific, that would include like the hows and the whys. My theory says that the amount of the apparent age of the universe, the amount of space in the universe, that is the scale of the universe, and the amount of matter in the universe are all indicators of the amount of information in the universe. So that and information kind of percolates into the universe. The universe has a history of accumulating information. As it does so, it accumulates age, a tighter scale of space, and more matter. And I don't want to go much further into it because it still.
Can you talk about the father of science? Who was considered the father of science?
Oh, I don't know, probably some Greek fella. Archimedes did a lot of stuff. He's my dude because he had a discovery while he was taking a bath, according to legend. He discovered the theory of displacement that was going to let him figure out whether the royal crown maker was stealing gold from the king and replacing it with crappier metal. And he makes this discovery, he's taking a bath, and then he's so excited he runs down the street naked. And I've been naked in public about 1,500 times, so he's my father of science.
You're famous for, didn't you one time put up a formula of some sort on a plane?
Yeah, I put up a dumb little equation that says, in real basic terms, that Planck's constant, which is a measure of the scale of space, or the blurriness of space, the way that DPI for flat screen TVs is a measure of the scale of the TV. You have HD, and then now you have Ultra HD, and then there's something beyond that. And all that is a measure of the number of pixels per linear inch. And Planck's constant is pretty much that for space itself. And my equation said that if you could cram enough matter into a small enough space, you could shrink Planck's constant.
Can you start, what was the whole rationale? Tell us about that story.
Well, when I was, right before I turned 21, I was sitting in my school cafeteria eating red Jell-O cubes, and I just read a little article about how short-term memory is different from long-term memory, that scientists had thought they'd discovered where short-term memories are stored. And I'm like, yeah, maybe, but that seems a little like bullshit, because I had the idea all of a sudden that there should be a geometric reason for why you don't remember most short-term memories and you do remember most long-term memories. And that is that you build more pathways to long-term memories. There are more angles to get at them. Like if I said first girlfriend, each of you guys would picture your first girlfriend. There are quite a few ways to get to that memory. First time you kissed, first time you were disappointed in life. I don't know. There's a bunch of ways to get things that happened to you in 11th grade or 9th grade. A lot of ways to get at that thing. If I said, first time you heard somebody say fiddlesticks, there's no memory accessible for that. It wasn't an important thing to you. You didn't, there's no context for you to remember somebody saying fiddlesticks. You didn't make enough associations with that moment for that moment to be accessible via just the cue fiddlesticks. Now, if that moment were more important, if fiddlesticks is what they say before, that's the signal for a firing squad to execute somebody, and your dad was executed by firing squad, well, that moment would have there'd be a lot of ways to get to that moment. It would be an important emotional moment, and fiddlesticks is part of that moment. But under existing conditions, fiddlesticks is nothing. And I thought there should be a geometry of memory which puts accessible memories in a more central place where they're accessible from a number of different angles, and trivial, unsupported memories kind of on the outskirts where it would take a very specific combination of prompts to bring back that memory. So basically a geometry of memory. And I forget what the original question was, but that
Is it about Max Planck or?
No, about, how you put that, you flew that equation on the.
all right, so anyway, so I thought, if there's a geometry of memory, that geometry is, I would guess, is similar to or identical to the geometry of the universe. If the universe is made out of information, and it's some kind of most efficient map of information, then an information space based on the information in our own brains would have the same physics as the physics and the same shape and dynamics, as the universe itself. Which includes things like the density of information, the amount of information, the distribution of the spatial distribution of information would influence the shape of space. So it's a general relativistic type theory that in some ways goes beyond general relativity, though without me being Einstein and having equations that actually describe, except for dumb, simple ones like the one I flew, that describe what's going on.
How much did you have to pay for that?
No, it's cheap. It's surprisingly cheap to tow a banner. This was 1986, and it was, I think, $200.
Did you paint the banner yourself?
No, you hire a guy and he builds the banner. He's got a certain number of pre-made letters that he can fit on a banner, and he I don't know, he attaches the letters to this big netting, this big kind of flag, and he just tows the flag.
And this was an equation you created. This was your own theory.
Yeah.
And what did it say on the banner?
It said that, that Planck's constant shrinks if you put, according to the amount of matter added to the point in space at which you're measuring Planck's constant. Which means you can never have a truly black hole, because if you throw enough matter into a potential black hole, that matter shrinks the scale of space so that because the scale of space is shrunk, that's the equivalent of expanding the size of the sphere of matter that's falling down, that's collapsing into itself. So it's self-limiting, that because space keeps expanding, the scale keeps getting tighter and tighter to reflect the more and more matter at this point of that it never reaches a point. There's always more space for it to fall into. It also suggests, there's a thing called Mach's principle that's never been mathematically substantiated, which says that inertia is based on an interaction between the thing that's moving inertially or staying still inertially and the rest of the matter in the universe. Based on the idea that if there were only one thing in the universe, you couldn't have inertia because there's nothing to measure motion against. Or to put it another way, if you had a spinning bucket of water, you spin a bucket of water and the water starts climbing the sides of the bucket because of the centrifugal effect. But if you had just a spinning bucket of water in the universe and nothing else, it's not a spinning bucket because there are no landmarks to measure the spinning against. So somehow this inertial motion has to be an interaction of the inertial object and everything else in the universe, including the 10 to the 11th other galaxies, the 10 to the 22nd stars,